After the LU decomposition, the next step is the substitution step for solving B, actually. So for that, once we decompose the matrix A, we will generate a solution for B in two steps. We will use these two steps, a forward substitution step, then a back substitution. In the forward substitution, we will be using L times D equals B. This L was found from A with the LU decomposition. And we already know B's, so we say that we will multiply L's by unknown D's, which will give us B's. So that means we will solve these using this forward substitution. So it is important to recognize that this merely amounts to performing the elimination manipulations on B. So basically we actually performed the Gauss elimination for A only in the previous step in the LU decomposition, but we didn't implement it for B. Now we are basically implementing it for B by solving this equation system. So thus at the end of this step, the right hand side will be in the same state that it would have been had we performed forward manipulation on A and B simultaneously. So after this step, it will be the same step as the Gauss elimination that we learned for solving the linear systems before. And the forward substitution step can be represented concisely using this formulation. Basically, we are going to solve this, and for that we need to subtract this summation of A and D terms multiplications from B to obtain these. So we will find these by isolating it. After finding the D values, now here, then it is ready to implement a back substitution by using this equation. So we have used from, again, LU decomposition. We used L here for this formulation, but U in here. X's are unknowns, and these are now the values after the forward substitution. And basically this step finally allows us to find the X values. Simply, the last term of these matrices will have only one term. That's why Xn will be determined by dividing D by A and N, which is inside this, the last diagonal term, A and N. And the rest of the X's will be obtained from the back substitution step, as we use the same as in the Gaussian elimination. So after implementing these, we will finding X values, and that's it actually. This is how we use the LU decomposition for solving the linear equation systems. Let's continue in the next slide to the example that we solved before for LU decomposition for A matrix. And now let's find the X values in the next slide. In the example, if you remember, we already obtained an L and an U matrix by decomposing A with the LU decomposition for this example in example 10.1, and the results were these. U is this and L is this. Now we are going to use this for the forward elimination and forward substitution and back substitution. Let's continue with the first step of substitution, which is forward substitution. So here, 1 forward substitution, and for that we are using, as we said before, L times D equals B. So we know L's here and B's here. These are B's, and we don't know these. We will solve for these actually. So if we want to solve for these, let's solve the first equation initially. Maybe we can write this and see how it works. Basically, we have 1, 0, 0, 0.0333333, 1. Let's write it here as 0, and 0, and 0.1, minus 0.02713, and 0. This is L. These are D1, D2, and D3, and B's are 7.85 minus 19.3 and 71.4. Okay, from here, now you can see that this is easy to solve. So 1 times D, 0 times D2, and 0 times D3 brings us only D1 is equivalent to 7.5. Then simply from here, from the actually first equation, let's say, from the first equation, D1 is equivalent to 7.85. So this is simple. In the second one, you can see we will multiply this row by this column. So this value times D1, and we found D1, and 1 times D2, and D3 doesn't exist, so it will be equivalent to this. From the second one, 0.033333 times D1, which is 7.85, plus D2 times 1 actually is equivalent to minus 19.3. Then from here, D2 is minus 19.5617. Finally, from the third one, you can see 0.1 times D1, which is 7.85, minus 0. Actually, this is 1. Here you can see it is 1. So 0.02713 times D2, and we found D2 as minus 19.5617 here, and plus D3 is equivalent to 71.4. Then from here D3 is 7.0843. This way we already found the D values. Then the next step is back substitution. And for that we have the formulation of U times X will be equivalent to D's actually. We will solve this. And for that we know U already over here. You can see U is here. X's are these. X's are unknowns, and D values are these. D matrix is this. So let's define those or write them here. Let's write U first. 3, 0, 0, 0.1, 7.00333, 0, minus 0.2, minus 0.293333, and 10.0120. And x's are not known, x1, x2, x3, and these are 7.85 minus 19.5617 and 71.4. From the back substitution means we start from the back, from here, basically multiply this row by this column. It is only x3 as you can see, and equivalent to this. So from there, x3 is equivalent to 71.4 divided by 10.0120. Then x3 is 7.00003. And this is just a round of error. So let's back substitute this to the second equation. And if we multiply the second row by this column, it will be equivalent to this one. That means 0 times x1 plus 7.00333 times x2 is equivalent to minus 0.293333 times x3, 7.00003. So let's show like this. Not hear me actually. Maybe like this here is equivalent to minus 19.5617, and from here x2 is minus 2.5. We found this 2. Then let's back substitute this to the first equation. So we go up, back substitution. From the first equation, 3 times x1 minus 0.1 times x2. x2 is minus 2.5, we already found it, and minus 0.2 times x3, and that's 7.0003 is equivalent to 7.85. And from here, x1 is equivalent to 3. Then finally we can write x values in a matrix form, in a vector form. 3 minus 2.5 and 7 actually. There is a round of error. We can write that too. Finally, we already found the x values, as you can see. In short, we are using forward substitution for L times D equals B and find D's simply by starting from the first term, because this is only D1. It can be solved easily, and substitute to the next equation, then the next, and obtain all of these. Then use it in a back substitution formulation here. U times x equals D. These are the values here. And you start from the back this time, from the last term, because it has only x3. Substitute is into x2, the second equation, then to the first equation, and obtain all results.